Hello, this is for 1C 15.1, and we're going to start to learn one of the most important concepts in vector calculus. It's called vector field. So chapter 15 is all going to be a very important material. And 15.1 is a very long session, so there's a chance I might break this into a couple parts, okay? Vector field, what's a vector field? Vector field basically is a vector, is a function, okay? It takes a point to a vector. So vector field is a function, okay? It's a function. And this function takes a point to a vector, okay? So let's say here's a function, right? Takes this a point to a vector. This for 2 dimensions, and this one's for 3 dimensions. Examples. Velocity field, okay, it's for running object. So let's say this is a river, okay, and this is a vector here, and the length of the vector is the speed of the water. So that's one example. Another example of gravitational field, Newton's law for gravitation, okay. Number 3 is electrical field and the Coulomb's law. Okay, so these are 3 very typical examples. We're going to talk about it. Okay, we're mainly going to talk about a few vector field. Actually, basically, we're all going to talk about it in some of the later sessions. So now we're going to learn how to graph first. Okay. So we learned about definition. Vector field is basically just like how we did about vector value function before. It's basically a function for the vector field also. So we know what vector field is, and then we know there's a couple examples related to vector field. And the next thing is we're going to learn how to graph these vectors. Okay, so we learn how to graph vector field. It's very tough to graph all of them, so I will just graph a couple of them, okay? And here's the example, number 6. They ask you, if you have a vector field, okay, this problem is about, how to, the problem is from your homework is about which one match the vector field and the problems and the problem they give to you. There's one more thing I want to mention also. Some students ask me if I would give studying guide to the test. I try to give you guys the problem I do here. That would kind of like a studying guide. I cannot send out studying guide because that I know that it's an open note. Okay, so student can have the notebook. If this is in class, I definitely give studying guide. So not in class, so I won't give studying guide. But in my video, okay, I will try to give you a problem that I may test you in the test. Okay, so here is a function, okay, vector field function, and then now I'm going to show a couple examples, pick a couple points. So I'm going to pick a very simple point. I'm going to let x, y equal to 0, 1. Okay, it's very, very simple. Oh, I'm sorry. I'm going to pick x, y equal to 1, 2. 1 and 2. Okay, then I put it inside here. So f 1 and 2 is equal to, it takes 1 to 0, takes a 2 to x, so means a 2, 1. So this is x. Okay. And so now we're going to graph. Okay. So you go 1, 2. So you go x equal 1, y equal 2 right here. Okay. From this point, it's a 1 and 2. And then you become a vector 0, 1. So you go one more unit up. Okay, so this is a 0, 1. So that's how you graph. And then you will see a bunch of them. So you can match the answer. This is the answer C in your note, in your home, the book. The next problem is that if I'm going to give you, I don't give you the graph, okay? You need it from scratch. So not to match, but graph from scratch. So this is number 10. So you're given a fxy is equal to y negative 2x. Okay, so first you need to know what is the percent first. So find the length of that. Okay, that is equal to y squared plus negative 2 squared, negative 2x squared, okay? And then you let it equal to a number c, okay? And then you're going to square on both sides, so y squared plus 4x squared equal to c squared. And then you can see this as a ellipse. If you want to divide c squared on both sides, so you can see, okay, it's actually a ellipse. And if you want to, you can divide the c on both sides, but you don't have to, because I don't need to graph this one. Now I just need to graph the vector. So to graph the vector function, okay, I'm going to pick a couple points. I pick xy equal to 0, 0, okay? So that means my f 0, 0 will just equal to 0, 0. So the first one is pretty simple. And then I go xy equal to 1 and 1. And then my f 1 and 1, 1 and 1 will equal to y is equal to 1. And then x equal to 1, so it's negative 2. And then I want to pick one more point. I pick 2 and 2. Then my f 2 and 2 will equal to y is equal to x equal, the second part is negative 2 times by 2, so it's negative 4. Then I saw a graph here, okay? So the first point is 0, 0, so right here in the center, origin. And then 1 and 1. And then I go to x equal 1, y is equal 2. So this is a 1 and 1, 1 and negative 2. Okay, so that's for the first one. The second one, 2 and 2. Okay, this is 2 and 2. And then I go to x equal 2, y equal 4. So 1, 2, 3, 4. So be like this. Okay. And so that's for my graph. And if you want to find out what the length is, you can just find the length. Okay, you just take, like for instance, for this one. So for this one here, if you want to find the length of it, you just take 1 square plus negative 2 square. Okay, so it's equal to square root of 5. So that means that the length here is equal to square root of 5. I forgot to label this one, so it's a 2 and negative 4. So it comes out as it looks like ellipse. If you draw everything, you pick enough point, it comes out like an ellipse. So this is the how to graph a vector field, okay? But of course, we're going to use a calculator graph, a computer graph. And if you use a computer graph, you can graph faster. But you still need to know what the shape is. It comes out, the shape looks, the vector field looks a little bit like a ellipse. Then the last thing is the characters of vector field. Okay, characters of vector field. There's a few very important character vector field carries. Okay, the first one is called conservative. What's the conservative means? Conservative means a path independent. Okay, this also means a path independent. What do you mean by path independent? It means that if I want to go from A to B, okay, if I want to go from A to B, it doesn't matter how you get there. You can get like this to get there, or you can like detour it and then detour and then finally get there. It doesn't matter how you go, or you're going to go straight. Okay, you carry the same amount of work. Okay, your work not change. Okay. Work is the same. The work is the same for all paths. The importance is your starting point and your end point. How you get there, it doesn't matter. Okay, it's all the same. So that is for conservative, it means. Okay. So most of the things we do in life is conservatively, especially in physics, okay? But there's a lot of things we also feel not conservative. In what kind of case it's not conservative? So it's something like river. If you go to an ocean or river, and then sometimes you step on different spot, you feel a little bit differently. That's because they're not conservative, okay? So from A to B, if a river here, okay? If you're gonna, this is my A and that's my B, okay? If you go from A to B, okay, if you go this route, maybe different, then you go this route, or maybe different, you go this route. That's because you might have some very dangerous spot here, or maybe here, okay? So then river usually is not conservative. If a conservative is like, then it's very safe. There's a conservative river or lake, okay? But I think ocean usually probably not conservative. So I don't know, because I think students who study oceanology probably know more. And let's see. So that was for river, right? And majority of the time, I think most of the times it's conservative, okay? So usually how you get there, you're going to, the amount of work is the same, okay? Conservative means that the work is the same for all paths, okay? So that's what it means. It means that you go from different paths, you're going to feel differently or you feel the same, okay? So it's not about the time you put there, it has nothing to do with it, okay? It's the work, okay? It's the work is same or not. So that's for conservative. So what about swim? Okay, when you swim upward, downstream, you say A. So if you're going to swim from A to in the river, you're going to swim from A to B. Okay, you said when you go downstream here, okay, I spelled it right. Okay, this is downstream. Okay, you said, well, I don't have the paddle when I go down because the water pushed me down there. If that's the case, then when you come back, you're going to expect this upstream. Then you're going to expect a difficult work. That's because the conservative is a path independent, okay? But the word's the same. Remember the word's the same? So that means it's a fair game, okay? So that means that if you go from here to here, you feel very relaxed, you don't need to paddle. But when you come back, you're going to be working very hard for it because it's a fair game, okay? So just like school, okay? If you want to take a class very difficult right now, okay? You work very hard for it. And then your future is a little bit more bright because hard work will always pay off, okay? So you work hard for it, you're going to gain. So trust me, okay? You whatever you work right now, okay? One day you're going to appreciate your hard work. It's a fair games, okay? So if you first swing up here, you're very tired, but when you go back, it's going to be very relaxed, okay? So that's why conservative is a fair game. Okay, so the amount of words is the same, okay? The same as a leave a rock. If you leave a rock, okay? My pronunciation, sorry. Yeah. R-O-C-K. R-O-C-K. If you're going to leave a rock, it's very tough. But when you drop it, it's very easy. Because it's a fair game. How come? Because you leave a rock, okay, and drop it off, it's a word for gravitation. Gravitation is the same everywhere, okay? So therefore, it's also a fair game. So gravitation is a fair game. It's a conservative. Okay, sorry, couldn't. Gravitation is a conservative also. So now, we learn about what is a conservative. Now we're going to learn how to judge for conservative, okay? So conservative, basically a couple of keywords, path independent, fair games, okay? So just remember these a couple of keywords. The next thing is about how you're going to judge, how to decide if a vector field is conservative. Okay, there's a couple things you can use it to decide. The first thing is if there's a function f, okay, functions, there's a function, not the vector field function, some type of function. If f is given, if s is given, okay, and you are also, there's a vector field here, okay, and there's a function f is also given to you. The first thing is you find the gradient of the function is equal to fx, fy, okay. Find the gradient function, okay. If this vector field is equal to the gradient, okay, if the vector field equal to the gradient of some type of function, then f is conservative. Okay, then f is a conservative. And so if in that case, okay, this f is also called a gradient field. Okay, in this case, f is also, so f is a conservative, is also a gradient field. And f is also a gradient field. So sometimes the people say, well, f is a gradient field, that means f is a conservative also. Okay, these are byproduct of it, okay? So that's how you do it if f is a given. If f is not given, then how do you do the problems? Oh, you know what? I'm going to show you an example first. Okay, let me show you an example first. And here's example number 20. Problem number 20. You're given a function f, x, y is equal to xq minus 2xy. Okay? And so they said that they said find the f is a conservative. They tell us f is a conservative. Okay, so they ask you f is a conservative, what kind of solution you can get from here? Well, obviously, because f is a conservative, so that means f should equal to this. Okay, then you will find out what's f equal to. Okay, they tell us it's conservative, then this will come out automatically. So these just equal to fx, fy, and f of x just equals 3x squared minus 2y. Okay, fy is equal to negative 2x. So that is the vector function. And now, what happens if f is not given? So if you're not given here, okay, how do I know f is a conservative or not? Okay, this time is not given to you. Okay, what can you go from from here? So if f is not given, then you have a couple ways to do the problems. Okay, and so when f is given, we just see for the vector field equal to the gradient, right? If f is not given, then how do I test it? So let's say for f is given as m n, okay, so vector field, and for 2 dimension, these are 2 dimension, we got 2 terms, we just need to measure del m to del y equal del n to del x. Okay, partial derivative with respect to m to y equal partial derivative n to x. If that equal, then it's a conservative. Okay, these are for, if that's the case, that'd be conservative. And if you have 3 dimension, okay, so I will have a f equal to m n p. And then how do you do it? You just need to find called the code. That's a new term. The code for f. What's the code for f equal to? Okay, so the code for f equal to ijk and you go del x, positive y, positive to z, okay, and then you go m and p. And how do you use it? It means you take the derivative, you take the positive p respect to y, okay, like that. And I'll show you how to do it later on. If this one should equal 0, okay, the code should equal 0, then that will be conservative. Okay, now there's a new term here now. What is a code? Okay, what's this? Okay, code means that just like for water, earlier I mentioned that for river, right? Sometimes you step on different path, you feel differently. When you feel different, that's because of code. Okay, the codes are making the force. Okay, doing some type of force, giving you some different type of force, and I will talk more about this later on. Right now, you just take it as it is first. Okay, code of the f, the code, the vector field is equal to 0. I'm going to talk about that later on, okay, in a little bit. Right now, I'm going to show you an example first. Okay, This example is about how to find the potential function. Remember earlier I said if f is given to you, okay, and then you're going to have a potential function. Okay, I said for f is given, okay, and if f is given to you and f is a conservative vector field, okay, well, how do I know? Sometimes they just tell you there's some kind of f there, but they didn't tell you what f is. But they tell this is a conservative vector field, okay? Oh, you know what? Maybe I should do it like this way. I'm going to take away this. I said, let me rephrase, okay? If f is conservative, okay, then f will equal del f, okay? So that if a conservative, that means you are also a gradient field, okay? Then I said, what is f equal to, okay? Maybe phrase like this. So here's a point number 38, okay? And they tell us that there's a vector field equal to x cubed plus e to the y, okay, xey minus 6, okay. So they ask you to find the potential function. Now I want to mention one more thing is that if you take math 2, you learn about exact. Exact is the same as conservative, okay? In 1C we call in vector field, in 1C we call conservative, but in math 2 differential equation they call exact. So this is, remember this is the same as m and n, okay? So from now on we try to use the m and n to represent that. So now we're going to find, we want to see if this is a conservative first, okay? Because the conservative, then we have that. So I go del m to del y, okay? Well, this is my m here, right? So del y just equal ey, okay? And this is my n, okay? Del n to del x, well, to del x, this is 0, this is just what ey also, okay? Because this is constant coefficient, this is 1. So always these two are equal to each other, okay? If they're equal to each other, then it's a conservative. Conservative. If we're conservative, then these is equal to each other, is that right? So now, I also know that, okay, my f of x, so del f equal to f of x, fy. So my f of x equal to also equal to f, okay, because a conservative, so f equal del f, so del f equal f, and that's equal to x cubed plus ey, and then xey minus 6, okay? Then I'm going to match them. So my f of x equal to x cubed plus ey, okay? And then I take, I integrate it because it's a partial origin, right? So I go f equal to x cubed plus ey with respect to dx, okay? So that's equal to 1/4 x to a 4th plus xey, and then plus any constant with just a y. So I use hy. And now I need to find out what hy equal to. So what I do, I take this function here, okay? I'm going to take the derivative with respect to y. So I'm going to put it up here because that's a little bit too low. So I'm going to continue. So I go fy equal to, that's 0, that's an x up to y with respect to y. So just this is a coefficient, that's just a ey. Because this is a coefficient ey, the derivative just do ey, and then plus h prime y. And this is equal to this, right? This match that xey minus 6, okay? And then that cancels, so I have h prime y equal to negative 6, then hy will equal to negative 6y, okay? And you don't need to put plus c here for conservative, you don't need to do that, instead we do it at the end. So I'm going to erase this part. Okay, so my vector field function, a potential function, f xy is equal to 1/4 x4 plus xey plus a minus 6y and equal to c. Okay, oh, there's a 6 here. Or you can go plus c, it's really up to you. It's just that in difference equation, that's how we state the potential function. But once c, it doesn't matter. So that's for how to find potential function. If you know the fields conservatively, okay? So remember, conservative field is the same, it's also called the gravitational field. But a lot of time in the engineering world, they just say gravitational field, okay? You need to know what they mean by that. They mean the conservative. Means there's a function, the gradient for some type of function equal to the vector field, okay? Equal to the vector function. So now, earlier I mentioned about code, okay? So the second character, okay, the second character is the code. What is the code? Okay, code f. This is a vector. It is a vector here. What this vector equal to? This vector is equal to, okay, the pushing or twisting force per area, okay? In the little tiny area, what's the pushing or twisting force, okay? The unit of the pushing and twisting force divided by per area, okay? This means divided, so per area. So this is dividing, okay? So the easy way to look at this is like that, okay? So let's say if I have a sphere, okay, little tiny red sphere, okay, little tiny bit only, very tiny, okay, and let's say you put it in the water, okay, or in the field, any field. I'm going to just use the water, and I'm going to use a blue pen, okay, and I'm holding it. So let's say I put this into water. I want to see the water have any cold or not. It means that any certain force in different area, you know, like that, okay? You go inside, you step into water, all of a sudden just push you away. Or some place you step into water and nothing happen. Okay, those are usually conservative. But you could step into a water that all of a sudden there's some kind of force under the water and then just push you down. So how do I test it? So what the engineer usually do, they put a little ball inside like a rock, okay, and they push it, okay, push it down here. They put in the water. If this is red things, the red sphere, it will turns, okay. If you put in the water, you hold it, okay, don't do anything, don't move it, you push it, and then if this is red sphere, okay, a little ball, if it turns, okay, if it turns, that means there's a code there, okay, there's a code there. So when it turns, let's say I just give an example, let's say it turn like this way, Okay. It turned because there's a vector field there. Okay. The vector field is not conservative. It's not just the vector field there, but the vector field is not conservative. So you use called the right hand rule. I hope the camera can see it. Okay, you right thumb rule. Okay, you hold it. So this is a flow going this way, right? So my finger pointing in the same direction, and then my thumb is the direction of the coal. Okay, so because I couldn't draw it right front, so I'm going to draw a little bit right here. Okay, so here is my coal. Okay, the speed of the vector is the length. Okay, the length is the speed of the rotation. Okay, so the length. Okay, so this is speed of rotation. Okay, and there's a the axis they spin on it, because this one's a spin on it too, right? It's spin on it. So that's actually a rock you put inside, you holding it. Okay, so wherever the spin exit, okay, so this is the spin X. Okay, that's a spin X. And your spin X will never change no matter where you put it. Okay, what changes? The change of the rotation. The rotation, what direction it rotate, that will change. Okay, but the direction of the coal and the spin X will never change. It stay the same. So if you're gonna move the ball to other place, okay, move to right here, and then this the spin of the rotation of the sphere, it may change, but this will never change. Okay. So let's say this one they spin it on the same direction. So let's say spin right here. But if you move to here, and they may not spin like that way. Okay, they may spin differently. Okay, we don't know. They might spin the other direction. Okay, so the spin of the rod, that can change, but the coal and the spin X, that will never change. So that's for what coal is. Okay, coal means that there's some kind of twisting and pushing force in that particular area. Okay, so that is what. And then next thing I want to do is to give you a couple important things now. Okay, first of all is the formula. Oh, I gave you the formula already. Okay, so I'm going to write one more time then. I'll teach you how to use the formula later on. Okay, so that's the formula. And if it's equal to 0, conservative, not equal to 0. So if it's equal to 0, be conservative. If it's not equal to 0, then not conservative. Okay, you want conservative because that's easy to deal with. Not conservative means that every spot in the river can be dangerous. Okay, and then I'm going to give you a couple things about coal. Okay, a couple property come out of it. Okay, this is a note. I'm going to change my marker. Okay, the code F equals 0 if only if F is conservative. It means that the code is equal to 0, then F is conservative. If F is conservative, it means the code is equal to 0. Because we know that conservative means path independent. How you're gonna go, you do the same work. So always there's no any special thing come out. So that's what it means, okay? And so I think that's basically, okay? So that's number, maybe one more thing, okay? Co-equals 0 means there is no pushing or twisting force, okay? So then it's a little bit safe. And in that little area, in the area, okay, means that in just that little area. I don't mean that in the whole thing, okay? So you have to test in every little spot. So you see which spot's gonna, remember this is measured per unit, okay? So all these are measured per unit. So maybe I'll put it right here. And so now we're going to do examples. So how we use the formula I gave you guys earlier, number 46. We are given a vector field, and that's equal to x squared z negative 2xz and then yz. They want to find the point is a 2, negative 1, and 3. They said at this point is a conservative or not, okay? That means that it's a co-equal 0 or not. Remember, it's a per unit area, okay? Just at this point, other point they may be different. Because this is 3 dimensions, so we use a co equal to I, j, k, del x, y, and then z. And then we put x squared z negative 2xz and then yz. Okay, so this is how you do. Okay, so you just take the derivative with respect to y here. Okay, this means respect to y, so you're gonna zi. Okay, and then now this come here respect to z, so you have a what? X squared k. Okay, and then s squared j. So this one's a z, so s squared j, okay. J. And then now k is this one. So it's a respect to x, so therefore you're negative 2zk. And then you come back, then you go subtract. And then you go y, there's no y here, so it's a 0, okay. And then you go x, there's no x here, it's a 0 also. So that's kind of nice. And there is z here, so it's minus 2xi. And then it comes out equal to z plus 2x. Okay, and then x squared. And then negative 2z. And then now you put the point inside, okay? Remember, when you talk about co, you're talking about a point there, and just in that little area, okay, that unit area, okay? Now, I'm not talking about the whole thing, okay? When you find the co. And then, so the co at the point 2, 1, 2, negative 1, and 3 will just equal to z plus 2s or z plus 2 of these, so equals 7, and then 4, and then negative 6. Well, this is always not equal to 0. So not equal to 0 means at that point it's not conservative. Okay, means if because one point is not conservative, that means the whole vector field is not conservative. So means there's a twisting, pushing force in these points. So therefore, this is not conservative. Okay, so when it's a conservative, then the code equals 0 in the whole vector field. So if the reverse is conservative, means that every point is safe. Okay, but when the reverse is not conservative, even though the one point has a code, then it's not conservative. Okay, so so that's what code means. Okay, so remember, okay, when they are not conservative, it means that there's a one point is not conservative, even the other point may be sorry, take it back. When it's not conservative, means there's a one point the code is not equal to 0. Okay, even the other point the code can be 0, but it's still not conservative because you just need to have one point so the code is not equal to 0, then they become not conservative. But if the code is equal to 0, then that's good. When the code is equal to 0, then every place is then the whole field is a conservative. Okay. So when they talk about conservative or not, they're talking about the whole vector field. And that is for conservative. The number 3 thing we need to talk about it. Okay. The number 3 thing we talk about it is about divergence. For divergence, okay, so now what is a divergence first? Okay, we learn about, I just want to summarize a little bit before we get to this part. We learn about character about vector field. The first is conservative. Okay, conservative means a path independent. Okay, means no matter what the path is doesn't matter. Important is the end point and beginning point. So that was a conservative. And to judge a conservative, we use a code. For 3 dimension, for 2 dimension, we use del m to del y equal del n to del x. And then if potential function is given, okay, then it's easier. We find the gradient. Since the gradient equal to vector field, that's also for conservative. Conservative means that there's no twisting or pushing force in the field, okay? But if there's a one point, the code is not equal to 0, then there's not conservative. Conservative means that every point there's no pushing, twisting force because you're equal to 0. If you're equal to 0, no matter what point you put in, it's going to be 0. Okay, it doesn't matter. So divergence, the last thing is about divergence. Okay, divergence of vector field means divergence means a move away. Okay, move away from the source. Okay, move away from the source. There's 3 types of divergence we normally see. One is they come out. Okay, they come out from so they move away from, this is the source. Okay, now for instance, boiling water. Okay, when the water boiling, the air, the steam comes out. Okay, so that is a divergence. So another one is, that's a positive divergence. So this is a divergence. We use a rotation. Maybe I put it right here. DIF. Okay, they use this rotation. One more thing is a divergence is how they measure divergence. They use the left flux. Okay, left flux. Divided by volume, per unit volume. So they measure by left flux divided by the volume in that the unit volume. Okay, maybe I put them right here, unit volume. And it's a scalar. This is a scalar. a nice conservative, cold is a vector, okay, but divergence is a scalar. In this case, this is a positive divergence, greater than 0. So that's the first one you've seen. The second one is the source from outside, but you're going inside a place. Okay. When you're going inside a place, like pumping air into a tire, okay, then your divergence is less than 0. So that's the second type of divergence you see. Sometimes they call thrust contraction. This is thrust expansion. Okay, so maybe I write it out also. This is thrust expansion. This is thrust contraction. Okay, and the last thing you will see is like this. So you have like, you go in and you come out right away. Oh, you come out. So you go inside, then you come out. Okay. In this case, your divergence F is equal to 0. Okay. This one has a low change. There's no divergence. Okay. So there's 3 divergence. The formula for divergence is pretty straightforward. Or in both cases like this. It's kind of like you turn the water on, then you forget to plug into you turn the water on in the sink, you forget to plug in, and the water goes out the sink. Okay, it's kind of like that. So you turn on the faucet, the water just going down. And you didn't get to save the water. And the formula for divergence is pretty straightforward. Okay, so here's a vector field equal to M, N, and then P. The divergence, so divergence is just a measured thrust. Okay, the divergent vector field is just equal to del M to del X and plus del N to del Y plus a del del P to del T. Sometimes you see some book, they use this notation. Okay, they also call divergent. This means a differential operator. Differential operators are derivative. And so let's import number 16(2). So we have F is equal to x squared z, okay, negative 2xz, and then yz. And then at the point 2, negative 1, and 3, they said at this unit that contain this point, what's the divergence comes out in that point. Okay, so let's say if you have a vector field, let's say this is my vector field here, this point is 2, negative 1, and 3. It means how the source comes out, like the water, let's say water comes out, how much water comes out is a measure the amount of the change of water comes out. Okay, when it come out of this little hole, and what's the speed of a changing? That's basically is the divergence, means the thrust changing comes out from this hole. And so the formula is very straightforward. So divergent F first, okay, is equal to del M to del X. So this will be 2xz plus this is 2y, that's a 0. There's no y here. Plus 2z, then be y. Okay, and then now put in this number. Okay, it's equal to, it comes out equal to 11. Okay, just put the X inside and the Y and the Z inside. Then that's what I get. So that's basically for today's lesson. Okay, so divergent, if they see this notation, also mean divergent. So that's all for today. So I just want to summarize it quickly for you guys. Okay, so F is a vector field. Okay, and then there's a couple things that comes out of, you know what vector field is. I already explained that. I just want to summarize it quickly on some of the stuff. Okay, so F a vector field, the character of this vector field. Okay, first one is conservativity. Okay, so you check how to do conservativity, and means a path independent, no code, cos equal 0. So that's a conservative. There's a potential function, and that's a conservative. And number 2, I talked about it today, is about code. Okay, code and conservative are they're not friends. If it's conservative, there's no code. There's a code, there's no conservative. These two does not exist at the same time. Okay, so for conservativity, there's no code. Okay, if there's a code, there's no they're not conservative. So code means a twisting, pushing force per unit area. Okay, so number 3, remember divergent. So divergent is how the fluid comes out from a point, how far they come out, to measure the net flux per unit. Okay, so that's all we do.